Fill in the following chart and then construct exponential functions for each part a to g. In order to create an exponential function, let's recall that an exponential function has the form a of x is equal to c times a to the x, where c is the initial value and a is either the growth or decay factor. If a is a number bigger than 1, then we have exponential growth. If a is a number between 0 and 1, then we have exponential decay. So for part A, the initial value is 600 and the growth or decay factor is 2.06. 2.06 is more than 1, so that indicates that this is exponential growth. What is the growth rate? Well, what we need to recall is that if something does not grow or it doesn't decay, then it keeps 100% of itself. And 100% is the number 1. So what we need to do is we need to compare 2.06 with 1, or we could convert 2.06 to a percentage and then compare it with 100%. So why don't we take that approach? 2.06 is 206%. How much more is 206% than 100%? Well, it's just 106% more. So our growth rate is 106%. What is the exponential function? Well, it's going to be a of x is equal to the initial value of 600 multiplied by the growth factor 2.06 raised to the x. Part B, we're given that the initial value is 1,200 and that the growth or decay rate is 200%. So is this growth or is this decay? Well, again, remember that if something doesn't grow or decay, then it remains fixed at 100%. If something decays, the most that it could ever decay by is 100%. Then there would be 0% left. Since 200% is more than 100%, we know that this must be exponential growth. What is the growth factor? Well, we need to add 200% to 100%. And 100% plus 200% is 300%. And when we convert 300% to a decimal, we end up with the number 3. So the growth factor is 3. And our exponential function is 1,200 times 3 to the x. In part C, we're given an initial value of 6,000 and a decay rate of 75%. So remember that initially there was 100%. We've taken away 75%, so that means that 25% remains. 25% as a decimal is 0.25. So our decay rate is our decay factor is 0.25. Our exponential function is a of x is equal to our initial value 6,000 times our decay factor 0.25 raised to the x. For part D, the initial value is 1,500,000. The decay is by 25%. So using the same reasoning that we used for C, if we start off at 100% and take away 25%, we would be left with 75%. Therefore, the decay factor is 0.75. The exponential function is the initial value 1,500,000 times the decay factor 0.75 raised to the x. For part E, the only difference is that we're given a growth rate of 25% instead of a decay rate of 25%. So instead of subtracting 25% from 100%, we'll add it to 100%. 100% plus 25% is 125%. And as a decimal, that's 1.25. So our exponential growth function is a of x is equal to 1,500,000 times 1.25 raised to the x. For part F, we're given an initial value of 7 and either a growth or decay factor of 4.35. Well, just like in part A, the factor is more than 1, so we know that this is exponential growth. If we convert 4.35 to a percentage, it's 435%. That's 335% more than 100%. So the growth rate is 335%. Our exponential growth function is a of x is equal to our initial value 7 times our growth factor 4.35 raised to the x. Finally, for part G, we're given an initial value of 60 and a growth or decay factor of 0.35. Well, 0.35 is a number less than 1. Therefore, this represents exponential decay. 0.35 as a percentage is 35%. That means that 35% remains after one time period. Well, if 35% remains, that means that 65% decayed. So the decay rate is 65%, and the exponential function is a of x is equal to our initial value of 60 times the decay factor 0.35 raised to the x.